In this video, we're going to begin to look at the volume of prisms and cylinders and how we go about calculating that. What's important to remember is if we think back to perimeter, if we were given a shape, perimeter was one-dimensional. In other words, I could picture tracing around the outside and I would get my perimeter or my circumference. That is why my units were always just centimeters or meters, always to the first power. The next thing we began to look at was area and surface area. Okay, same idea. What happened there is I would begin to look at the same sort of distance in the sense of a length, but then I would also give something a width and say, I want to know how much space this takes up. So then we started getting formulas like length times width, or in the case of a circle, some pi times radius times the radius. I multiply two sides together, which is why I begin to look at units like centimeters squared or meters squared. They're to the second dimension. They're two-dimensional because it has a length and a width. We're going to begin taking a look at something called volume. Volume is the three-dimensional, where we start having that length, that width, but then we also start giving it a depth as well, or length with height, okay? Some places might call it, okay? So I start giving length, width, and a certain height. Okay, depending on which way it's angled. So we start having things that are going to be centimeters cubed, meters cubed, so something to the third power. So basically, like what we did with the last slide when we had length and we multiplied it by width, okay, we got the area. With volume, what we're really doing is taking, in a sense, this base here and extending it back, adding that third dimension. So just about every volume formula, at least for prisms and cylinders, can be described as the volume is going to be the area of whatever the base is times whatever the height is, whatever that depth is, whatever is not that base. Okay, how far back would it extend? So if we begin looking at a triangular prism, okay, let's say I gave you that this height is 6, this side is 4, and let's say this side was 10. Well, if I look at it, this here, the triangle, is going to be the base because that's what's on both sides. This side here is rectangular. So a prism, the sides have rectangular sides, are rectangular except for the base. So I'm going to find what the area of the base is. So in this case it's a triangle, so it's going to be 1/2 the 6 times the 4, in other words 12. So then to calculate the volume, it's going to be the 12 given by this base times then the 10 given by how far back that base extends. So in other words, my volume is going to be 120 units cubed. Okay. Look at a rectangular prism. In other words, like a box shape. Okay. this formula, the volume is going to be just given by length times width times height. Well, where does it get the length times width from? Well, if this front box is 4 and 6, well, that's going to give me this area of 4 times 6, which is going to be 24. And let's say it extends back 10 spaces. So I'm going to say it's times 10. Well, in this case, the volume is going to be 240 units cubed. Okay, let's take a look. Cylinders look a little complicated, and they are in a sense because of the circle. So if I tell you that my radius is 2, and that this is a height of 10, well, once again, my base is a circle shape, so the area of the base is going to be pi times 2 times 2. In other words, 4 times 3.14. So basically it becomes 12.56. So that provides what the area of this base is, what the circular region is. So to find the volume, I take that area of 12.56 and I'm going to multiply it by how high is this cylinder, in other words 10. So in this case my volume is going to be 125.6 units cubed. And there you go, that's a lesson of volume of prisms and cylinders.